Hi, welcome to my video on atomic structure. By the end, hopefully we'll be able to describe protons, neutrons and electrons and describe the distribution of mass and charge in an atom. We'll hopefully also be able to explain the term isotopes. As chemists, we usually use a model of a nuclear atom, first put forward just over 100 years ago by Ernest Rutherford. As seen in the drawing, an atom is made up of protons, neutrons and electrons. In this case, the carbon atom, we can see the green dots are electrons, they have a negative charge. The blue dots are protons, they have a positive charge. And the red dots are neutrons, they don't have a charge. You can see from the diagram that protons and neutrons are larger than electrons. However, this diagram misrepresents those actual sizes. Electrons are 1/2000th of a size of a proton or a neutron. The essential features of this model are as such. Firstly, protons and neutrons make up the nucleus, which is at the centre of the atom. Secondly, electrons, represented here by an E-, orbit the nucleus in shells. The third and fourth points are that the nucleus is tiny compared with the total volume of the atom, and it is also extremely dense and makes up almost all of the atom's mass. And lastly, most of the atom consists of empty space between the tiny nucleus and the electron shells. If the nucleus was the size of a single grape, the outer electrons would be 1.5 kilometres away. This table from the OCR AS textbook shows the relative mass and charge of a proton, neutron and electron. Protons have a positive charge, electrons have a negative charge, that we already know. An atom has the same number of protons as electrons, so an atom is electrically neutral. A proton has virtually the same mass as a neutron, and protons and neutrons make up almost all of the atom's mass. Most elements are made up of a mixture of isotopes. So what is an isotope? An isotope is an atom of the same element with a different number of neutrons. We know that neutrons have a relative mass of 1, therefore isotopes of the same element have different masses. They still have the same number of protons and electrons, but they have a different number of neutrons in the nucleus. In Greek, isotope means at the same place. The word isotope is used for different atoms of the same element that occupy the same position in the periodic table. We can describe an isotope using two different numbers. The first is the atomic number, also called the proton number. As you've probably guessed from the name, the atomic number or the proton number represents the number of protons in the nucleus. The second number is the mass number, also called the nucleon number. The mass number represents the number of protons and neutrons in the nucleus. Don't forget that electrons have an almost negligible mass, so the mass is entirely made up of the mass of the protons and the neutrons and excludes the electrons. We can use these numbers to write the symbol for an isotope, which we'll see an example of on the next slide. So, using what we've just learned about writing symbols for isotopes, we are going to now look at the different isotopes of carbon, and we're going to draw these in their symbols using the mass number and atomic number in their correct places. We're going to start with the most traditional type of isotope of carbon, carbon-12. The chemical symbol for carbon is C. Carbon always has 6 protons, and carbon-12 also has 6 neutrons. 6 plus 6 makes 12. So we have the 6 protons and the 6 neutrons make a mass number of 12. We're now going to look at carbon-13 and carbon-14. We're going to draw them out, and then I'd like you to take a guess at how many neutrons are in each isotope. So, how many did you guess? We'll start with carbon-13. So, Carbon-13 has 6 protons and has 13 as a mass number. 13 minus 6 equals 7 neutrons. So, doing the same for carbon-14, we can also work out how many neutrons it has. Again, it has 6 protons and a mass number of 14. So, minus the 6 protons away from the mass number leaves us with the number of neutrons, which in this case is 8. Different isotopes of the same element react in the same way. This is because chemical reactions involve electrons. The neutrons make no difference whatsoever to the chemical reactivity. Ions are different to isotopes. Many atoms react by losing or gaining electrons to form charged particles called ions. Ions can therefore be positively or negatively charged because they can have a different number of electrons. They can gain electrons or lose them. This means they have a different number of electrons to the number of protons. Don't forget, in isotopes, the number of protons and electrons remain the same even though the neutron number changes, and therefore the mass number changes. Here we have 2 different atoms of sodium. Notice their atomic number and mass number are both identical. However, the second sodium atom has a plus drawn in. This is to demonstrate that it has lost an electron. So electrons carry a negative charge. Losing an electron means that the atom is left with a positive charge, and we show this putting a plus after the atom. So, what have we learnt today? We've learnt the difference between protons, neutrons and electrons. We've learnt about where they can be identified in the atom. So, protons and neutrons are found in the nucleus and electrons are found in shells. We've also learnt about isotopes and understand that even though they have different masses, they undergo the same chemical reactions. We have learnt how to write the symbol for different isotopes. We've also learnt about what an ion is and how to draw the symbol for an ion.